The National Electrical Code, or NEC, has been built up through revisions and additions over the years. This has led to a complex document. A complete rewrite could streamline and simplify the code. Some sections of the NEC are outdated and do not reflect current industry practices or the latest technology. The language used in the NEC can be unclear and open to different interpretations. This can lead to inconsistent application of the rules and potential safety problems. Because the NEC is very technical, it can be hard for people who are not experts to understand and use correctly. On the other hand, a complete rewrite would be a big project that would take a lot of time and money. Rewriting the NEC could mean changes to existing electrical systems. This could disrupt businesses and cost more money. The NEC also serves as a record of electrical safety practices and rules over time. A rewrite could erase important lessons learned from the past. A complete rewrite could introduce new mistakes or oversights that might not be noticed until after it is implemented. Instead of rewriting the entire code, the NEC could be updated and clarified step by step. This would address specific problems while keeping the basic structure intact. Industry best practices and new technologies could be added to the NEC. This would provide practical advice and reduce confusion. Improving training and education programs about the NEC could help people understand it better and reduce confusion. The complexity of the NEC and the possibility of making it better are valid concerns. However, rewriting the entire code is a complicated and potentially disruptive task. Other ways to improve the NEC, such as making small updates, adding best practices, and improving education, might be more practical and effective. Firstly, the NEC has evolved over time through multiple revisions and additions, resulting in a complex and sometimes confusing document. A rewrite could streamline and simplify it. Secondly, some sections of the NEC are outdated and do not reflect current industry practices and technological advancements. Thirdly, the NEC language can be ambiguous and open to interpretation, leading to inconsistent application and potential safety issues. Fourthly, the technical nature of the NEC makes it challenging for non-experts to understand and apply effectively. Firstly, a complete rewrite would be a massive undertaking requiring significant time and resources. Secondly, rewriting the NEC would likely require changes to existing electrical installations, potentially disrupting businesses and incurring additional costs. Thirdly, the NEC serves as a historical record of electrical safety practices and regulations. A rewrite could potentially erase valuable lessons learned from past experiences. Fourthly, a complete rewrite could introduce new errors or oversights that may not become evident until after implementation. Firstly, instead of a complete rewrite, the NEC could be updated and clarified incrementally, addressing specific areas of concern while maintaining the overall framework. Secondly, industry best practices and emerging technologies could be codified into the NEC, providing practical guidance and reducing ambiguity. Thirdly, enhancing training and educational programs on the NEC could improve understanding and reduce confusion. The NEC complexity and potential for improvement are valid concerns. However, a complete rewrite is a complex and potentially disruptive undertaking. Alternative approaches, such as incremental updates, codification of best practices, and educational initiatives, may be more feasible and effective in addressing the NEC challenges. The National Electrical Code, or NEC, serves as the cornerstone for electrical safety in the United States. Its primary function is to safeguard people and property from hazards arising from the use of electricity. The code encompasses a wide range of electrical installations, including wiring, overcurrent protection, grounding, and equipment. It is updated every 3 years by the National Fire Protection Association, or NFPA, through a consensus-based process involving a diverse group of stakeholders such as electrical engineers, contractors, inspectors, and manufacturers. The NEC history dates back to 1897, when the need for standardized electrical practices became apparent due to the rapid growth of the electrical industry. Early versions of the code were relatively simple, but as technology advanced and new electrical applications emerged, the NEC evolved to address these changes. Over the decades, the NEC has grown in size and complexity, reflecting the increasing sophistication of electrical systems. The NEC is not a static document. It undergoes continuous revisions and updates to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. The code's development process is open and transparent, allowing for public input and participation. The NFBA uses a committee system to review proposed changes and develop revisions to the NEC. These committees are composed of experts in various fields of electrical safety. The NEC is organized into chapters, articles, and sections. Each part of the code addresses specific aspects of electrical installations. Chapter 1 contains general requirements that apply to all electrical installations. Chapters 2 through 7 cover specific types of occupancies, equipment, and wiring methods. Chapter 8 deals with communication systems, and Chapter 9 contains tables and examples. Understanding the NEC requires a thorough knowledge of electrical principles, wiring practices, and safety standards. The code is written in technical language, and its provisions can be complex and nuanced. It is essential for electrical professionals to stay up to date with the latest edition of the NEC and to seek clarification when needed. The NEC is adopted by state and local jurisdictions, and it becomes legally enforceable once it is adopted into law. Electrical inspectors are responsible for enforcing the NEC and ensuring that electrical installations comply with its requirements. Compliance with the NEC is crucial for ensuring electrical safety and preventing electrical hazards. Electrical contractors, engineers, and installers must adhere to the code's provisions to protect people and property from electrical shock, fire, and other hazards. The NEC addresses a wide range of electrical safety issues, including overcurrent protection, grounding, wiring methods, equipment installation, and hazardous locations. It provides specific requirements for each of these areas to minimize the risk of electrical accidents. Overcurrent protection is a critical aspect of electrical safety. The NEC requires the use of fuses and circuit breakers to protect electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of electricity when a fault occurs, preventing damage to equipment and reducing the risk of fire. Grounding is another essential safety measure. The NEC requires electrical systems to be grounded to provide a low impedance path for fault currents. This helps to protect people from electrical shock and to prevent the buildup of static electricity. Wiring methods are also carefully regulated by the NEC. The code specifies the types of wiring that are permitted in different locations and the methods for installing and supporting wiring. These requirements are designed to prevent physical damage to wiring and to minimize the risk of electrical hazards. Equipment installation is another area of focus for the NEC. The code provides detailed requirements for the installation of electrical equipment, such as transformers, motors, and appliances. These requirements are intended to ensure that equipment is installed safely and that it operates properly. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. The NEC has specific requirements for electrical installations in these locations to minimize the risk of ignition. The NEC is a complex and comprehensive document, but it is essential for ensuring electrical safety. Electrical professionals must have a thorough understanding of the code and its requirements to protect people and property from electrical hazards. The NEC is constantly evolving to keep pace with technological advancements and emerging safety concerns. It is important for electrical professionals to stay up to date with the latest edition of the code and to participate in the code-making process. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years to reflect new technologies and best practices. While the NEC is a valuable resource, it can also be complex and difficult to navigate. There are several reasons why a complete rewrite of the NEC might be considered. Firstly, the NEC has evolved over time through numerous revisions and additions, resulting in a document that can be cumbersome and difficult to understand. A rewrite could streamline the code and make it more user-friendly. Secondly, some sections of the NEC may be updated or inconsistent with current industry practices. A rewrite could ensure that the code reflects the latest technological advancements and best practices. Thirdly, the NEC language can be ambiguous or open to interpretation, leading to confusion and inconsistent application. A rewrite could clarify the language and make the code more precise. However, there are also several arguments against a complete rewrite of the NEC. Firstly, a rewrite would be a massive undertaking that would require significant time, resources, and expertise. Secondly, a rewrite could disrupt existing electrical installations and require costly upgrades. Thirdly, the NEC has a long history and represents a significant body of knowledge and experience. A rewrite could potentially discard valuable information and lessons learned. Finally, a rewrite could introduce new errors or unintended consequences. Instead of a complete rewrite, there are several alternative approaches that could be considered. Firstly, the NEC could be updated and clarified incrementally, addressing specific areas of concern while maintaining the overall framework. Secondly, industry best practices and emerging technologies could be codified into the NEC, providing practical guidance and reducing ambiguity. Thirdly, educational initiatives could be enhanced to improve understanding and reduce confusion about the NEC. The decision of whether or not to rewrite the NEC is a complex one with significant implications. There are valid arguments on both sides of the issue. Ultimately, the decision will depend on a careful assessment of the costs and benefits of each approach. The National Electrical Code is a living document, constantly evolving to address new technologies and challenges in the electrical industry. While the idea of a complete rewrite might seem appealing to some, it's crucial to consider the potential ramifications and explore alternative solutions. One of the primary arguments for a complete rewrite stems from the inherent complexity of the NEC. Over the years, it has been amended and revised numerous times, resulting in a document that can be difficult to navigate and interpret. A fresh start could allow for a more streamlined and user-friendly code. Another reason to consider a rewrite is the presence of outdated provisions. The electrical industry is constantly advancing, and some sections of the NEC may not reflect current best practices or technological innovations. Updating these sections could improve safety and efficiency. Clarity and consistency are also major concerns. The NEC language can be ambiguous, leading to inconsistent application and potential safety hazards. A rewrite could provide an opportunity to clarify the language and ensure that the code is applied uniformly across the country. The complexity of the NEC can also make it difficult for non-experts to understand and apply effectively. A more user-friendly code could improve compliance and reduce the risk of electrical accidents. However, there are also strong arguments against a complete rewrite. The cost and time involved would be substantial. Rewriting the NEC would require a significant investment of resources, and it could take years to complete the process. A rewrite could also have a significant impact on existing installations. Changes to the code could require costly upgrades to existing electrical systems, potentially disrupting businesses and homeowners. The NEC also serves as a historical record of electrical safety practices. A rewrite could erase valuable lessons learned from past experiences, potentially leading to unintended consequences. There is also the risk that a rewrite could introduce new errors or oversights. It's possible that a new code could contain unforeseen problems that could compromise safety. Fortunately, there are alternative approaches to addressing the challenges of the NEC. Incremental updates can be used to address specific areas of concern without disrupting the entire code. This approach allows for continuous improvement and adaptation to new technologies. Industry best practices can be codified into the NEC, providing practical guidance and reducing ambiguity. This can help to improve compliance and reduce the risk of electrical accidents. Educational initiatives can also play a crucial role in improving understanding and reducing confusion about the NEC. Training programs and educational resources can help electrical professionals stay up to date on the latest code requirements. In conclusion, the decision of whether or not to rewrite the NEC is a complex one with no easy answer. While there are valid arguments on both sides, it's important to carefully consider the potential costs and benefits of each approach. Alternative solutions, such as incremental updates, codification of best practices, and educational initiatives, may offer a more practical and effective way to address the challenges of the NEC.